In addition to using the addition and multiplication principles to solve inequalities, we also can add to our toolbox the reciprocal property. So, for example, if we have a positive number, its reciprocal will also be positive. So for example, 2 is positive, so 1/2 will be positive. Likewise, if a number is negative, its reciprocal will be negative. Now, if we have a number a that's positive but less than b, finding the reciprocal, those numbers will both of the reciprocals will be positive, but the reciprocals will change which one's bigger. So, for example, 2 is less than 4. If we take the reciprocal, 1/2 and 1/4, 1/2 is bigger, even though 2 is smaller. So 1/4 will be less than 1/2, which corresponds to what we're seeing here. Likewise, if we have negative numbers and a is smaller, then its reciprocal will be larger than the reciprocal of b. So let's take a look at an example. Here we have 0 is less than 4 over x, which is less than or equal to 2. So these are both positive numbers because they're bigger than 0. So if we find the reciprocal, that would be x over 4 and 1/2, the inequality changes direction. So whenever you find a reciprocal, the inequality changes. Now, x over 4 is greater than or equal to 1/2. We can now multiply both sides by 4. So x over 4 times 4 and 1/2 times 4. And we multiplied by a positive number, so the inequality stays. So x is greater than or equal to 2. So our set notation would be set of all x's where x is bigger than or equal to 2. Now, if we graph that on the number line, we'll be looking at the values to the right of 2, and the interval would be 2 to infinity. Now let's look at this one. Let's rewrite that negative exponent, right? Because 2x plus 8 to the negative first would mean that we have 1 over 2x plus 8. Now, these are both positive because they're bigger than 0. So let's flip them. Let's find the reciprocals. So 2x plus 8 and 3/2. And the inequality switches direction. Now we can subtract 8 from both sides. And this means that we have 2x is greater than negative 13/2. Now we can divide both sides by 2. So this means we have x is bigger than negative 13/4. So if we find that on the number line, that would be negative 3 and 1/4, and x is bigger. Notice we're using a parenthesis at the negative 13/4 because we have no equal bar. So in set notation, we have the set of all x's where x is bigger than negative 13/4. Interval notation, we would have negative 13/4 to infinity.